Hello and welcome to Spur Economics. Today, we're diving into the concept of multicollinearity. We'll discuss its causes, consequences, and possible solutions. Please like, share, and subscribe if you like our content. Visit the Spur Economics website for more knowledge on econometrics, link is in the description. Multicollinearity is a situation where the independent or explanatory variables in a regression model have a strong relationship with each other. We call it perfect multicollinearity if the variables have an exact linear relationship and their correlation coefficient may be 1. Even if the problem of multicollinearity is imperfect, that is, correlation coefficient is less than 1, it can have serious consequences on the parameter estimates. In cases of perfect multicollinearity, models cannot determine parameters or coefficients because the independent variables exhibit a perfect correlation. In such situations, models cannot distinguish between the influence of given independent variables on the dependent variable. It becomes impossible for the models to separate the effects of the variables. Therefore, we cannot determine their coefficients. In other words, the model fails to explain the effect of each independent variable on the dependent variable. Imperfect multicollinearity also poses serious problems to the accuracy of econometric models. In the presence of less than perfect multicollinearity, we can determine the estimates or coefficients. However, the independent variables still exhibit high correlation, resulting in large standard errors of the coefficients. Hence, the estimated coefficients have low accuracy or precision. Multicollinearity is inherent in economic variables because they tend to move in similar directions in many cases. For instance, consider the consumption function shown here. In this equation, CIT is consumption, Y is income, and W is wealth. The variable wealth, for example, could be measured using the value of assets owned. We commonly observe a high correlation between the independent variables of income and wealth. Both these variables may increase or decrease together at somewhat the same rates, leading to the problem of multicollinearity. High-income households or individuals also have high wealth or assets, and vice versa. This is applicable to cross-sectional, time series, and panel data studies. As a result, this model might suffer from the consequences of multicollinearity due to the inherent nature of variables. In time series analysis, multicollinearity is a common problem because economic variables tend to have similar variations over time. For instance, economic variables like employment, income, consumption, and investment increase during periods of a boom in the economy. Similarly, they decrease during periods of slump or recession. As they tend to vary in a similar manner, the inclusion of these variables may result in multicollinearity in the model. If the correlation is high, it can cause problems in estimation of models. The use of lagged variables in econometric models can cause multicollinearity. For instance, a consumption function may include a lagged income variable. That is, consumption depends on current income as well as previous or past income. In the equation shown here, we have included one lag of income along with current income and wealth in the consumption function. The current income variable and lagged income will most likely be highly correlated and cause multicollinearity. This happens because previous period income is usually quite similar to current income. Moreover, all the variables of income, wealth, and previous income might be highly correlated in this model. Hence, models with lagged variables can often have a serious problem of multicollinearity. We can detect the presence of serious multicollinearity using the variance inflation factors or VIF. In addition, we can use a combination of the correlation coefficient, R-square, and standard errors of the coefficients to assess whether multicollinearity is a serious problem in a model. We will discuss these methods of detecting multicollinearity separately, and you can find a link to it in the description. Now, let us suppose that we detect multicollinearity and discuss some possible solutions to it. If multicollinearity is seriously affecting the results of the model, one of the solutions is to simply drop the variable causing the problem. This can be carried out in case of variables that are unimportant from the economic perspective. However, dropping important variables can undermine the model, so it is not always advisable. For instance, wealth should not be removed from a consumption function because this can lead to specification errors. In some cases, multicollinearity is not a serious problem, that is, the parameter estimates are not seriously affected. Some presence of multicollinearity can, therefore, be tolerated in certain situations. It is also possible that the overall results from the model are satisfactory. Even when multicollinearity does not allow accurate estimation of parameters separately, the overall effects of the variables are still captured by the model. If the overall model or some of the variables are significant, those estimates can still be used for forecasting. Moreover, variables with multicollinearity can also be used for forecasting if the pattern of multicollinearity remains the same in the forecast period. In time series analysis, multicollinearity is a common problem because of the use of lagged variables. However, using different forms of these variables can eliminate this problem. For instance, instead of including lagged variables, it is common practice to employ first difference or second difference transformations of the variables. In practice, time series analysis has several methods such as VAR, VCM, ARMA, ARIMA, and other models that may be better suited for time series. Generally, economic variables have intricate relationships with each other. It is possible to introduce new equations and variables in the model that make better economic sense and capture the relationships between different variables. If you found this video helpful, don't forget to like, share, and subscribe to our channel for more in-depth discussions on econometric topics. Leave your questions and comments below. See you next time.